During the period of October 1957 through April 15, 1958, the Convair 880 commercial jet airliner began major component construction. Many subcontractors and vendors contributing parts and sub-assemblies from all over the country began making deliveries. The 880 program moved into full swing as the first production model of Convair's commercial jet airliner program was scheduled for test flights early in 1959. Significant in the period leading to this report was the construction of a complete metal mock-up in 880 tooling jigs, a metal mock-up that is being used to finalize all tubing, harness, and interior installations well ahead of production schedules. The swept-wing Convair 880 will be capable of operating from all airports throughout the world, now handling 4-engine piston aircraft. The ruggedly built Convair 880 was specifically designed for economical medium and short-range operation. But with the addition of the wing center section fuel system, it converts to a highly efficient long-range liner. In any range, the 880 is designed to provide the finest in passenger and operational services. 2 plug-type doors are located at each end of the fuselage for easier passenger handling. Opening or closing can be accomplished by the stewardess with a minimum effort. When the door is pulled to the fuselage, it slides downward and wedges into place and is safely secured in one simple motion. The interior features unique appointments in every detail of comfort and convenience. Standard seating arrangements will accommodate 88 passengers in luxury flights and 109 in the coach configuration. An airline crew can convert first class to coach in a few hours. The high safety qualities incorporated in the new dual window arrangement offer each passenger his own private viewing area. The 880 air conditioning system was developed and tested as a part of the 880 test program. 44 general outlets, along with 109 individual passenger outlets, supply a complete change of fresh temperature-controlled air every 2.5 minutes in the passenger area and every minute in the smaller flight deck spaces. The 2 galleys have been compactly designed for efficient service. The spaciousness of the 880 cabin allows for more comfortable passenger seating arrangements than ever before possible. The advanced designs in 880 cockpit lighting eliminate distracting reflections and keep the instruments in the cockpit area glare-free. The glare shield keeps the windshield free from instrument panel reflections. White and red dimmable floodlights are used to eliminate the tunnel effect created by the shield. Similar floodlighting is available throughout the cockpit. The new use of printed circuitry makes each panel more compact and increases the effectiveness of the new improved dimmable edge lighting. The lighting designs incorporated in the flight engineer's panel simplify the operation of the 880's systems. In the newly constructed Convair Acoustics Laboratory, extensive sound testing has been conducted to determine the best material to be used in soundproofing the 880 cabin. The material to be tested is installed in the window separating a live room from the completely soundproofed room on the other side. In the adjoining soundproofed room, sound readings are taken. Over 100 materials have been tested in this way to determine the best possible soundproofing material to be used in subduing jet engine and aerodynamic sounds in the cabin area. On the outside of the metal fuselage section here in the large reverberation room, sound levels simulating the noise produced by the 880 engines have been established. Acoustic tests are first conducted on the bare metal fuselage section, and then different layers of soundproofing materials are added in a series of build-ups with tests in each stage. This is continued until a full-scale cabin mock-up has been completed and tested. Then furnishings are removed, testing is completed, and a final soundproof configuration established. In the General Electric plant in Evandale, Ohio, the CJ805 engines, 4 of which power the 880, are being manufactured. The military version of this engine is being used in the Convair-built B-58 Hustler, the world's fastest bomber. The Minnesota Mining and Manufacturing Company in St. Paul, Minnesota, contributed to the success of the Convair-developed manufacturing process called Scotch weld. This is a process that combines added structural strength with a greater fuel tank integrity, making possible the maintenance-free integral fuel tank. This design permits the use of the interspar box structure as a fuel container and gives maximum range with minimum maintenance. The Scotch weld tank has not developed a single case of fuel leakage in over 4 years of rugged military use in hundreds of F-102 and F-106 interceptors. The Scotch weld process begins in the cleaning baths built especially for the construction of the 880 at a cost of over $500,000. In the cleaning bath area, the parts to be Scotch welded are cleaned, chemically treated in special tanks, oven dried, Scotch weld primed, and force dried in the curing oven. In the assembly area, the Scotch weld adhesive film with its protective backing is applied over the drilled sections where metal is to be joined to metal and drilled to match the holes in the metal sections to be assembled. The protective backing is then pulled away, leaving the translucent Scotch weld film in place. And the fuel-tight rivets are driven. The completed wing assemblies are brought to the giant 880 oven built especially for final 880 wing curing. The $175,000 oven installation was thoroughly tested using a pair of R3Y wings similar in size to those of the jetliner. Once the oven curing is completed, the wings are ready for mating. At Convair's structural test jig, the Scotch weld system is once again tested in an 880 wing section. The purpose is to demonstrate the fuel-tight integrity of the Scotch weld integral wing fuel tank by load cycling under pressure and adverse temperature conditions. Testing is done at temperatures ranging from 65 degrees Fahrenheit below zero to 160 degrees Fahrenheit above. Internal pressures range from 3 to 10 pounds per square inch. External load cycling pressures exceed 13,000 pounds. Medium-range transport aircraft are subjected to more strenuous punishment than long-range transports, and these highly successful tests have subjected the 880 wing to stresses far in excess of those that will be encountered in normal operation. No fuel leaks have occurred in any test conducted. The last of the famous Convair 440 liners in service throughout the world reached the end of their assembly line as the earlier phases of the 880 tooling program began. With the completion of the highly successful Convair liner program, over 1 million square feet of floor space became available for the production of 880s. The near-sonic speeds of the 880 require a higher degree of precision construction than ever necessary in the slower commercial airliners of the piston era. Pioneered by Convair in supersonic F-102 and F-106 interceptor construction, optically aligned tooling jigs are used to build the 880.
More than 400 in-flight test hours have been completed by the 3 test 880 jet airliners involved in the program. The availability of these aircraft to meet flight schedules has been the best of any aircraft ever tested at Convair. 3 and 4 engine minimum takeoff performance and maximum effort landing investigations were conducted at the Air Force Flight Test Center at Edwards Air Force Base, California. These tests were conducted to determine takeoff capabilities at various weights and required runway lengths using both 3 and 4 engines. Minimum landing distances and rejected takeoff distances were also established. Over 200 stalls were completed in the program to determine slow-speed flying characteristics in varied configurations. Fuel jettison on the 880 is accomplished through 4 fuel nozzles located in pairs near the aft tip edge of each wing. The nozzles eliminate the customary extendable dump chute. They are permanently fixed with no moving parts and no maintenance requirements. The pattern is such that fuel can be jettisoned at all speeds without impinging any of the aircraft surfaces. Flow rates for the system were established as being well above those required. It is able to dump 51,700 pounds in a period of 20 minutes, 65% faster than minimum requirements. Each of the 3 test aircraft is specifically instrumented for the particular group of tests being conducted during any given flight. Basic data receiving equipment includes an airborne tape recorder for permanent record and a direct reading oscillograph. 2 photo panels containing all instruments pertinent to the test. A temperature recorder automatically keeps a record of temperatures in all areas of the ship throughout the entire flight. During flutter tests, telemetering is used. In these investigations, the pilot contacts the facility and initiates the test event by means of a countdown. All flutter flight activities are monitored here in the telemetering facility. Once a test has been initiated by the pilot, data is transmitted as it is produced on the aircraft to recorders capable of handling 20 separate data functions at one time. In addition to the permanent record, discriminators break the incoming RF frequencies into voltages that are graphically interpreted in visual form for an immediate quick look evaluation. With the test satisfactorily completed and tabulated, clearance is then given by the facility to the aircraft to continue to the next checkpoint. Both here in San Diego and at the Edwards Flight Test Facility, extensive testing was done on the thrust reverser system developed jointly by Convair and General Electric for the CJ805-3 engines that power the 880. Over 100 taxi runs were made to establish cascade settings that would achieve optimum efficiency. During all test flights completed by the 3 880 test aircraft to date, no engine changes have been made as a result of engine failure. The 880 is now leaving production lines on regular schedules, ready for delivery. During the test program, it has proven its ability to land and take off well within performance predicted limits, and in level flights has more than met speed performance guarantees by demonstrating its ability to fly at its optimum estimated speed of 615 miles per hour. All Convair testing has been concluded, and emphasis is now shifting to final Federal Aviation Administration certification testing. Certification will be completed by spring 1960, with first deliveries beginning in November of 1959 to Transworld and Delta Airlines. This then is the Convair 880, the world's fastest jet airliner. Structurally and performance-proven, luxuriously appointed, versatile, the most advanced jet airliner available to the flying public today.